Okay, so this is our 5th example that we have with 3D reactions, and we have a platform with a center of mass G, which we'll notice is not quite centered, and we want to determine the force in each of these cables. So we have a spreader beam, and maybe a crane is picking this up, and we have some cables coming down off that spreader beam, and so we want to find the tension in the cables as we hoist this thing up into place. 2 megagrams. Don't freak out. You all know what a megagram is. Normally we work in kilograms, and remember a kilogram is times 10 to the 3rd grams. So a megagram is times 10 to the 6th. And because I'm super weird, I like to have things in kilograms, especially if I'm going to multiply them by gravity. So this would be 2,000, okay, times 10 to the 3rd kilograms. So that's how I like to look at it. I recognize I have cables. So again, I'm going to have to find the coordinates, and I can see that here we are at 6, 0, 0. Up here at C, we are at 6, 3, 4. Over here at B, I am at 6, 6, 0. Over here at E, it doesn't really matter. We are going straight up in the Z direction, so we can just call that tension D to E. And so now I need to go back and kind of get this sketched in. And let's get our x-axis kind of in the same direction, so it kind of all looks the same. Get our y-axis going. And we're going to get our platform on here. And it looks like I did not make that very square, but it'll be fine. It's not very square at all. It's kind of skewed. So I have this tension D, and it is at 3 meters and 3 meters. And I have a point kind of up here. And so we are pulling up, and we are pulling up, and it's symmetric, and then we have this point G that's going to be coming down in the Z direction. So we have 2,000 times 10 to the 3rd kilograms times 9.81 meters per second squared. This is a mass, and we are summing forces, so we need to make sure that we multiply by gravity to make that, okay? So if I look at, I have tension in AC. If I look at symmetry, I can already see that tension BC has to equal because they are symmetric. And if I go through and write my unit vectors, I'm pulling up C minus A, C minus B. Then I can write out that TAC equals the tension in AC times 0I plus 3/5 J plus 4/5 K. And the reason I know that is this is a 3, 3, 4, 5 triangle. We are in one plane. We are in the ZY plane. So we don't have an X component. 3, 4, 5. So I have 0I plus 3/5 TACJ plus 4/5 TACK. And if I look at TBC, it's going in the opposite direction, but it's still a 3, 4, 5. I'm going to have 0I minus 3/5 TBCJ plus 4/5 TBCK. And now I can go back on here and I can go ahead and draw that I have 4/5 TAC, 4/5 TBC. I can have 3/5 TAC and 3/5 TBC. I'm calling this positive because I'm showing its direction as negative, so I don't need to call it a negative. If I wanted to show it in the positive direction, I would have to include that negative, but because I'm visually showing it, we're good. Okay? So we have all of our unknowns, we have all of our tensions, And, you know, we just start at the beginning. If we sum forces in the x direction, well, all of my forces are in the z-plane and the y-plane. So I don't have anything going on there. So let's sum forces in the y direction. And I'm going to get that 3/5 TAC minus 3/5 TBC equals 0. So TAC equals TBC, which we already determined by symmetry. Okay? So we can just call that T. If we just want to call these all T now and not confuse ourselves, we can call them T. Now we're going to sum forces in the z direction up. And I have 4/5 T plus 4/5 T plus TD minus 2,000 times 10 to the third times 9.81 equals 0. So I can add these up and I get 8/5 T plus TD equals 2,000 times 10 to the third times 9.81. And I have one unknown, two unknowns, and that is not super helpful. So I need to come up with another equation. So we could sum moments about the x-axis coming out, wrapping around to the back is positive. If I'm on the x-axis, these kind of go away. TD, will it cause a positive moment about the x-axis? Indeed it will. TD times 3 meters. Okay? This force pulling down, if this was a door and I pushed down on the door, would it cause rotation? Yes, it would. Minus 2,000 times 10 to the third times 9.81 times 3 meters. Okay? Y component pushes straight through, but we have this 4/5, it's going up, so it would push the door around in a positive manner, plus 4/5 T, okay, because we said all of these could just be T's, times 6 meters equals 0. So again, I have 3 TD, okay, plus 24/5 tension equals 2,000 times 10 to the third times 9.81 times 3. I'm just simplifying and I'm pulling this over. And so I have another equation, TD and T, TD and T. So that's when we start the algebra. I can rewrite this that TD equals 2,000 minus 8/5 T. And I can say 3 equals 2,000 times 10 to the third times 9.81. Okay. 3 times TD, if I pull this over, minus 8/5 tension plus 24/5 tension equals 2,000 times 10 to the third times 9.81 times 3. Okay. I'm going to have to simplify this, pull the T out, combine these, and pull that on over. So if I've done my algebra correctly, I can solve for tension, which is the same thing as TAC, which is the same thing as TBC, and I get 4,087.5 kilonewtons. Okay? Once I determine that, I can go back up to either this equation or this equation and solve for TD. When I do that, I get that TD equals 13,080 kilonewtons. When I use this equation, I get TD equals 13,080 kilonewtons. So I'm pretty confident I calculated the right number because this value for my tension makes both of these statements true when I find that TD is 13,080. If I wanted to check again, I could come back and I could take moments about the y-axis. And now that I know these values, I could have 4/5 times tension times 6 minus, that's a negative, minus 4/5 tension times 6 plus, and I could take this times 2, and I should get that 0 equals 0. And again, that is like the beautiful thing of statics, is you should never have a wrong answer because your equations should hold true. It doesn't matter where you're taking your equilibrium points about. You should end up with the sum of my forces equals 0. The sum of my moments equals 0. And you should be able to say check and check.